Mobile Mighty God, I'm Master Sankoshi, and today I want to have an introduction to Granular Flow Module in Computer Multiphysics Simulation Software. The Granular Flow Module. The Granular Flow Module is used to model the bulk behavior of flow of granular materials. Granular flow simulations are used to model the behavior of macroscopic particles such as sand grains, foods, or pellets when subjected to external forces like gravity, vibration, or shear. Unlike fluids or solid, granular material can exhibit both solid-like and fluid-like behavior depending on their packing confinement and stress conditions. Granular flow is important in a variety of applications, including pharmacology, geotechnique, additive manufacturing, and food processing. Most of the physics interfaces in computer multiphysics use the finite element method to compute fields such as temperature, fluid velocity, electric potential, concentration, or displacement. In contrast, the granular flow provides a Lagrangian description of a problem in which the particles are treated as discrete entities that can interact with external fields, with boundaries in the surrounding geometry, and with each other. Granular flow is based on the discrete element method DEM, which treats the particles referred to as grains, as a sphere is three-dimensional, or cylinder two-dimensional, or maybe extra-dimensional, occupying space in the computational domain. Grains are allowed to collide with each other, and which the boundaries, walls, contact force models are utilized to determine the resultant grain deformations and contact forces. Their trajectories are computed in the time domain by solving a set of equations based on the Newton's law of motion. Both translational and rotational degrees of freedom are accounted for and are updated every time step based on the forces and torques resulting from contact and external fields. Heat transfer effects on the grains can also be included that by tracking the temperature of each grain. A grain's temperature can change due to an external heat source, convective heat transfer with the surroundings, and conductive heat transfer due to grain and grain wall contacts. The granular flow module also offers a wide variety of release mechanisms to control how the grains are inserted into the geometry. Grains can be released directly into the domain or along the boundaries. By default, grains are released such that they don't overlap with other grains or walls. After the simulation is complete, many dedicated tools for visualizing grain motion and reporting grain statistics are available. The granular flow module supports simulation in two and three space dimensions, or maybe more. So I need to give a very briefly explanation about this granular fluid that, as you see, there are such as sand, grains, food, and pellets, or maybe some sort of ashes. When we have this granular, as I told you, they can have a both behavior such as a fluid behavior or solid behavior, and it's very interesting that they can have a extra dimension, and these forces it can be such as gravity, vibration, or shear stress. For example, if you press some part of sand or ash, there is a vibration in that, and also in acoustic pressure, gravity. For example, if you cast, for example, some granular, you see that they scatter and they have a trajectories that they can have a collision to each other, or they can have a collision to the another sections. So it is possible that someone come and scatter and cast some granulars to a boundary, for example, a house and carpet, and the possibility that they can just stay there, or by some forces such as stepping, it can be has a vibration and go to the air or go to the bond of the geometry, for example, a body. Now I want to go to the granular module physics interface guide. Each comes from mathematics physics interface. For example, the granular interface expresses the relevant physical phenomena in the form of sets of partial or ordinary differential equations together with appropriate boundary and initial conditions. Each feature added to the physics interface represents a term or condition in the underlying equation set. These features are usually associated with a geometric entity within the model, such as a domain, boundary, edge, point. The granular flow interface also includes features that are associated with the grains and global features that are not associated with any geometric entities in the model. The granular flow module offers the granular flow interface found under the fluid flow branch. The model result. This interface models the bulk behavior of granular materials by computing the individual grain trajectories under the influence of external forces and contact forces. Figure 1 uses the application library example mixing grains in a Robinson mixer to show the model layer tree structure and the settings window for the selected physics interface node. This node acts as the starting point for the granular flow simulations and has option to choose the contact force models, rolling resistance models, and additional options to include the thermal effects. A granular flow model must contain at least one node each to specify the material and contact properties of the grain and balls. Additionally, at least one feature that releases the grain must be included in the model. You see, we have a model builder, and in the top section, in global definitions, we have equations added by the feature. At the next step, we have highlighted nodes shown in settings window. Then we have a grain and wall properties. Then we have a contact properties, release features, additional features, contact force, model. Figure 1 shows the model layer to the left and the setting window for the selected feature node. To the right, the equation section in the settings window shows the model equations. So thank you so much for watching my tutorial video until the end. Also, you can download the proper and appropriate concept physics file simulation which is related to this granular and grain structure. Today is 22nd of the May 2026. Time is 4:33 p.m.